Oh, I will leave it to you, Stu.
Fair enough. I didn't know if you're going to take it. Good morning. Welcome to the KubeVirt community meeting. This is November 7th, 2018. We have a few agenda items to cover, so let's go ahead and get started. First up, I sent an email this morning to propose moving the VMCTL repository. Currently, it's under Fabian's personal account, but if we're going to be bringing this under the KubeVirt umbrella, it might make sense to do so. And so I sent that email. I actually already hit the button to fork the repo, which is a mistake because that's not how we should have done it anyway. So we will be cleaning that up. If you have noticed that the repo already exists, that's my fault. We'll fix that. Looking for thoughts or comments on that in terms of moving it over, if there's any objections or thoughts on that. Okay, quiet crowd.
Yeah, so no, just side note. So there has been disagreement about that feature, and I acknowledge that. Although I think the problem is we have by now, I think around 50 repositories on KubeVirt, all of them to a different degree of ripeness and maturity. And that's, I'm not happy about that state, but I don't see a better solution for that. I think we want to concentrate stuff which is about KubeVirt in that org. So even for features like this, like VMCTL, or we have different opinions on, I think it's right to move it to KubeVirt. But what I think we should think about, and I thought about it, is how we differentiate between ripeness of repositories, right? We have like incubating projects or non-ripe ones, and some which we can really recommend to use. And actually, I wondered if we choose a different place to separate them by location, right? So something like KubeVirt and KubeVirt Incubator, then they are different orgs and we lose visibility. So I rather thought if a first step could be just to add certain tags. I mean, KubeVirt GitHub repositories can be annotated with tags if we're using tags to differentiate like incubating projects from something else, just to have some baseline information about how we define the ripeness. Otherwise, it's just a mass of things. Maybe there are opinions.
Well, I do actually have a thought on that. When you look at the Kubernetes project, from which we're sort of a related project to that, it becomes difficult, especially when APIs are moved from alpha to beta because they physically move modules and import paths break. Whatever we do, I'd like to not do that. If we have some sort of like metadata marking on a repository, that's great. But in terms of physically moving things around, that causes a little bit of pain for consumers.
So I think I agree with Stu and the notes about the namespaces and stuff like that. What I think would work really well is the tags idea. And actually, as far as GitHub, that's the only solution I know of as far as how to do that, unless you get into a branching method or something like that, which is just ugly. So I think your proposal on using tags is actually a great idea.
Actually, I might have a different one. Right now I'm looking at the list of all the repositories. I'm not sure, you see the tags, but they're not differentiated in any way. So basically you have 3, 4, 5 tags per repo, but you can actually add something visible to the beginning of the description, to the single line description. That's actually differentiates it from the tags, and it would set the repo apart. And it's part of the description, so you should always see that even when you click through to the repo.
You mean the very top line above the code itself, the short one-liner?
Yeah.
Like in the README, is that where?
No. There is when you open a repo, basically you see the repo name, then you have the tabs with code issues, whatever, and then you have one-line summary of what the repo is about.
Oh, yeah. I see what you mean.
I would take both, because the good thing about tags is you can really query them. So we could really.
That's true. That's true.
So I think both make sense, and I would actually propose to start simple and just say like incubating, and all the others just don't have it, so that you can query for incubating projects. And we would also say that if it gets an incubating tag, then the description needs to be prefixed with incubating. That would be my pragmatic.
Yeah, sounds good to me.
Well, I think to your point too is, if you really wanted to make it super visible, you could also add we could have a label in the README that just shows up right at the get-go, right? So that it's very clear to anybody, even if they miss the tag. Anyway, just an idea.
Yeah. Okay. I can take that as an action item to go through the repositories and add the incubating label to my likings. And then everybody can complain next week if they want to get rid of that.
Yeah, I think the easy thing about the descriptions and labels is that you can touch that without touching the source code.
Yeah.
So.
Yeah, we don't need to do any relocation, a website update, all that nasty stuff. Yeah. Okay, cool. So, Stu, that means I would actually start with, once you have that, once we move vmctl, then I would actually attach it, tag it as incubating, and I would do so for other repos as well. Okay, cool. Thank you.
All right, so to be clear on that moving of the repo, because we've already forked it accidentally, a project admin will have to be the one to actually delete it because it's a very dangerous operation. So it's not allowed.
Yeah, I think I just looked and I have not seen vmctl in KubeVirt.org.
All right, well, it's there. So moving on to the next topic, Windows driver disks. Peter.
Yeah, I'm here. Ah, cool. So I finished the work on this part, and cool thing is, from KubeVirt perspective, we actually don't have to do any new code. Only small needs have to be implemented. What this is about? It's about providing drivers just before Windows install. Meaning, if the user has virt.io drive, he needs to have an option to install virt.io drivers. If he has some custom hardware in his data center that is not recognized before the installation, it has to have the driver before, so the Windows recognizes it and can use it. From this part, we have to split the implementation into steps, providing the virt.io drivers and allowing cluster admins to build the repository of its drivers. As for the virt.io, cool thing is that we can actually take over the process and distribute the drivers ourselves from the KubeVirt. The registry disk can be used for this part. It will be fairly straightforward. We create a registry disk and put it in the Docker Hub alongside the KubeVirt. It will be pulled, and from the user perspective, he can just set in the YAML file virt.io disk, and it will be directly used as any other registry disk. From the second part, from installing it, any other custom drivers, this can be done a little bit differently, but again, the parts are already there. We can utilize containerized data importer, which allows cluster admin to build its own cluster repository with disks, and the disks are then mounted as data volume. As long as in both cases, virt.io, even in the other drivers, the disks are present before Windows installation, Windows will correctly recognize them and allows you to install the Windows drivers for any hardware you want. This is the 1,000 miles overview from the feature I've been working on.
May I ask a stupid question?
Yes.
So is it effectively that the work you did or envision is that you prepare some disk, so volume or container registry disk, and they are attached as regular disks to the VM, and there is no code change needed in KubeVirt?
Directly in KubeVirt, no.
Okay, so the thing effectively, what the work you did is covering to provide these disks, right? To provide the driver disk.
I've been working on the research how to do it, not to implement it yet.
Okay, that's cool. But the research then is focusing on how to provide the driver disks.
Yeah.
Okay, cool. Thank you.
Sorry, typing on mute. Any thoughts as far besides that one? All right, then next up, just a quick note about virtual machine instance PCI addresses. I added this for you, Vladik. I thought it was an important enough topic that we should cover.
There's not much to talk about there really. We just enabled this option to set PCI addresses for disks and network interfaces that are using VirtIO. Depending on the chipset, different addresses can be allowed, and we expect the libvirt to provide the feedback whether the address is correct or not. So the error will be floated from libvirt itself.
And that has some ramifications in the sense that we can't do this at a validating webhook level, or we're going to end up duplicating all of libvirt's existing logic. So we have to actually attempt the creation of the disk and let the error trickle back. Is that correct?
Yeah, absolutely.
I have a favorite question of everybody's. Is there a way to read them back once the VM is running? Just for the sake of discussion, let's think about export VM scenario, for example, where you might want to...
So your question was to read them back? I didn't understand that.
Yeah, exactly.
What does that mean?
Well, once you start a VM... Well, no, sorry. You provide an explicit addresses. Okay. For the defaulted ones, that was a different topic, but still, I guess currently we have no way to get the addresses as a whole for running VM, right? Let's say for export VM, maybe.
Not from within the VM, you mean?
No, from outside, from the management perspective.
So the question is, when you look at the virtual machine instance YAML, it is not for disks that don't have a specific address that they are requesting. We're leaving that blank, and then libvirt will decide: is there a way to read those addresses back from libvirt and actually find them at the cluster level? Is that the question?
Yeah, that was exactly that.
So I don't think that we actually do have a mechanism at this point to read those back. Kind of my opinion on the matter, which is just mine, is that if the user doesn't specify it, it's because the user doesn't care. I get that we're talking about Windows activation and and we want to keep the virtual machine as like as possible during future incarnations. But at the end of the day, if it wasn't specified, does it really matter?
Well, yes, it doesn't matter to the user, but we already discussed this in the past. If the user exports the VM and imports it into second cluster, just for the sake of conversation, Windows might start installing drivers. They might not require reactivation. Well, as Vladik said a month ago or so, Windows are much more tolerant right now. I'm not sure about Windows 7, but recent versions are pretty tolerant. But anyway, they might install drivers. And they definitely do that when you just take your USB key and plug it to a different port. That's annoying. And people are filing bugs sometimes about that. So I just wanted to know if there is a way to get it out. There isn't, and we'll have to figure that out sooner or later.
We were thinking about a mechanism, but I think, none of this is being worked on at the moment.
Right, yeah. At the admin level, you can definitely go in and inspect the libvirt domain XML, but it's absolutely not helpful for what you want, which is an API level thing, which, yeah, I don't think that exists at this point.
Yeah, it answers the question.
All right, any other questions on that? And moving on to the Virt IONet multi-queue. Fabian, did you write that?
That might be, but I think somebody else worked on that.
No, I just, it's me. I just want to briefly mention that recently we've merged we've enabled the multi-queue function for Virt IONet. And basically we set the number of queues, the number of virtual CPUs on the queues. We merged recently the documentation for this, and I don't know, just try it out.
Yeah, I actually have a question about that. Vladik, do you think it's a good idea to enable that by default on high-performance VMs? Do you think it will work?
I don't know. I don't know. There are a few issues there that I wouldn't enable it just unconditionally. It depends on all kind of different things. It depends on the traffic that you expect to have inside the guest, and there are all kind of different implications. It also consumes MSIs, MSX vectors, and depends on how many network devices do you have and how many virtual CPUs overall you have. So it's kind of, people need to decide for themselves whether they need this or not.
Thanks.
All right, thank you. Next up, Virt control image upload. I had added this note even though Mike Hendrickson owns this. But basically, the idea here is that this feature just barely missed 0.9 because it was still under review when we cut the release. So we are attempting to backport that currently. I don't know if there's any other thoughts on that.
Yeah, just side note. So, I mean, this is about KubeVirt, right? And we as Red Hat, we plan to do a stable release based on the release 09 branch, and that's why we favor picking that feature into the release 09 branch. Usually we don't want to pick features, but that sounded like a justified interest. It brings a lot of convenience for the user, so that's the reason why we said, we as maintainers said, right, to pick that features. Yeah, so anybody who wants to take one of these release branches as a stable branch can always raise features he would like to get cherry-picked, and then we can discuss it on a case-by-case basis. In general, release branches are just for security and other bug fixes.
Roger that. Thank you. And now to talk about the disk device cache, Marcin.
Yeah, so a few words about this device cache. So from now in KubeVirt, we support two cache modes, which is none and write-through. And if file system supports direct I/O, then non-cache mode will be used as default. So I think that's it. No more about that.
So the two modes were none and write-through, you said?
Yeah, write-through and none. These two.
Okay. Any questions, anybody? All right. Ihar, SRIRV.
Okay. The PR is still in review. There were quite a bunch of useful comments yesterday. I need to follow up on that. There was one comment about testing this whole thing. Roman suggested that we should have some node in our CI cluster with the PCI device that would be able to be served by the SRIV device plugin. And then we would have a functional test that would actually, well, first we would have probably a provider that would actually configure everything. And then we would have a functional test that would test it end-to-end, including allocation of the VMI with this SRIV device, and then checking apparently that it's actually allocated and whatnot. So I'm very happy to serve with the functional tests. I'm not sure how I'm not sure whether it's in the realm of possibility to get us a node with in our CI system with the device, and so I wonder is it worth pursuing, or we can live with a functional test that is disabled unless an SRIV device plugin container is there, which I think we already do for some of the tests for Malthus, I think. So I would plan to do that in a similar way. So yeah, what's our take on CI?
Yeah, I mean, I could take a look that we get a box from our pool somehow with an SRIV device to be used for CI testing. And we do have conditional tests like for Windows and for Multus, right? We do only do that conditionally. What I wonder is, can't we emulate an SRV capable device? I mean, no, somebody's shaking his head. Because
Well, I think there's, as far as I know, there's no like ready-to-use component, but I may be wrong. Open to suggestions. It would be nice to have, yeah.
I was trying to find something similar to this when I was working on OpenStack, and I didn't find anything that was stable enough and useful.
Yeah, in OpenStack we always had some third-party nodes that happened to have the device. We never had an actual emulation layer, sadly. Yeah, and there's also a question here of how to automate the deployment of it. My plan was to just add support in Ansible playbooks. My understanding is that CI is not using them. Maybe I'm wrong, but that it has like this KubeVirt CI repo with a bunch of bash scripts that actually prepares the environment. So it seems like it may be duplicative to do it in both places. But anyway, like I think the main question is whether we have a chance to get the hardware. If so, we can probably go and solve the tech issues there.
Yeah, actually, do you think you can resolve that? I mean, we know that we have a pool of hardware. The question is that we need to sort out if we can use that for upstream testing. Because I think we would have devices, right? Like in our internal systems. And I just wonder if we can integrate that somehow, yeah, with upstream testing.
I don't know.
Yeah, we can take that offline and see.
Okay. Yeah, but I will still add the task. That's a good suggestion. And other than that, there's a bunch of things, parallel things happening in the device, in the SRV device plugin that will enable us to support some additional stuff, like actually properly support multiple SRV networks, reducing privileges in the containers. But this is all depending on the progress in the upstream. Though I think we're getting close there, which is good. Yeah.
Do you have some more details there? I mean, yes, yeah. What would be supporting that? I mean, what upstream change is helping us?
Well, first change there that we will adopt is support for multiple separate PCI device pools. So you can actually have different resource names for different PFs. And also you can configure that one of the pools is using, let's say, VFIO, and another one is NetLink, so you can have them separated. And so first, it allows us to actually have two different SRIV NICs on the node that are connected to different segments, and have them properly allocated, and not just one random VF from one of these devices, which is happening so far. And also, it allows us to actually properly register the VFIO device nodes through a device plugin API. So this actually allows us to reduce the privileges to the container, because now we will have the devices properly registered in C groups for the containers. Yeah, and another thing that is happening in the device plugin is adding some kind of a mutation hook that would fill in the limits and requests in the pod spec for us, because currently you need to, for VMI, you need to attach it to a Multus network and also specify the limits and requests explicitly, which is not nice because we already have this information at the Multus network. So there will be a hook that will handle that for us. yeah, this is two main things.
Yeah, Ihar, can I have a question?
Sure.
Is there already support in the scheduler to select the right node that provides the necessary NICs? Like when you create a VM with VFIO usage, do we know to not schedule it to hosts that do not have any NICs like that?
Well, device plugin already registers corresponding resource names as allocatable. So the Kubernetes scheduler should already not pick the node that doesn't have them.
So, and our controller already converts the request for such device to pod specifications, right?
In general, yes. That's what I was mentioning, that there will be a hook that will automatically fill in the requests for us, and then it will magically happen. For now, you still need to explicitly say which devices you need in the VMI spec. This is going to change.
Okay, thanks.
Ihar, could you link to that upstream, to the discussed upstream changes? Could you please add that link to the minutes?
Okay, I will add them.
Thank you very much for the effort.
That was a lot of typing, but I think I caught it. Any other thoughts on that topic? All right, moving on. Archim, would you like to give an update on fencing?
So I have some updates. We succeeded to create some integrated environment that includes two components, like cluster API external provider and node recovery component. So we also succeeded to run the whole flow. So in the case if node start to be non-responding from some reason, networking or maybe KubeVirt gone, node recovery will we'll see the change of the node, we'll monitor the node, and we'll delete the relevant machine object, and external provider will run actuator of the specific machine and will power off first with the node and after power on the node via power management. I also updated a little bit node recovery repository with some documentation and with some architect diagram that show connection between components, like between external provider and node recovery, and that's pretty all. Thank you.
Thank you. I would ask me as a user, I'm just using KubeVirt. What benefits do I have from the work you do when you're done?
I believe in the end, I believe also Kubernetes will have some positive sides from our work, because when node lost connection with the master, it just all the pods that currently run on the non-responsive node will have state node lost, and so Kubernetes cannot rerun them because they can have some persistent volume, and Kubernetes does not really know if it's just some kubelet problem or some network problem, or really the node has power off state. So in our case, we will run fencing command that will restart the node, and in the case if it was some network problem, restart can solve it. So so master will restore connection with the node, and will shut down all pods, and will restart pods from space, I believe. that's pretty possible scenario. And after it, I believe we can extend our node recovery controller not just to, for example, to restart the node, but also if after restart master cannot restore connection to the node, I believe our controller can start to shut down pods from some way to start to make possible for master to start them to restart the pods on some other node. Also, when master does not have connection with the node, but I believe we still will need to check how we can do it.
All right. Yeah. So it sounds like there's some. So thank you for the details. I think we'll hear more down the line, right? Because it sounds like in an early stage. Looking forward to how that then really looks in reality. So thank you.
All right. Any other notes for the open floor, or excuse me, for the agenda and notes?
Yeah, so side note here. We will do a meetup at KubeCon in Seattle. It will be during the conference days. So that was unclear until now, but now it's clear that we will do something. We still need to get some place where to do the meetup, but it's at least set in stone that we'll do it.
All right. And are there any other notes for the open floor? Thoughts, comments? All right. Well, thanks, everybody. It's been a productive meeting.
Just small note, I will attach some demo to the document, so if someone wants to take a look at it, you are welcome.
Awesome. Thank you. All right. And with that, I guess we'll see everybody next week. Thanks for joining.
Thank you. Bye-bye.
Bye, guys.
Thank you. Bye-bye.